Hi, we are Group 5 and we'll be exploring the oral microbiome in this video. To start off, did you know that the oral microbiome is one of the most diverse microbial communities in the human body just after the gut? It contains more than 700 bacterial species and provides a complex environment for microbial colonization and interaction. The exact definition of oral microbiome is the collective genus of all microorganisms residing in the oral cavity. It is closely related to oral dysbiosis, which is an imbalance or destruction in the oral community, arising from various factors such as disease, poor oral hygiene, medication use, and diet. Our oral microbiome holds tremendous significance for human health in several ways. First, it plays a critical role in maintaining oral health by creating a balanced ecosystem where beneficial bacteria help protect against harmful pathogens. When this balance is maintained, it prevents conditions like tooth decay and gum disease, maintaining good oral health. Second, the mouth serves as a unique microbial habitat with distinct niches. Unlike other body sites, it provides both hard surfaces like teeth and soft tissues like gum and tongue, each creating specialized environments for different microbial communities to thrive. Third, these different areas harbor specialized microbial communities that interact with the host. The bacteria on your tongue are different from those on your teeth or gums, and each community has evolved to perform specific functions in their particular location. Finally, and perhaps most importantly, the oral microbiome plays a key role in systematic health conditions. We will explore more on the next slide.
The oral microbiome maintains a careful balance between beneficial and harmful microbes, which is essential for keeping the mouth healthy. When this balance is preserved, good bacteria help protect against disease-causing pathogens by competing for resources and supporting immune defenses. However, when this balance is disrupted, it can lead to common oral diseases such as dental cavities. Dysbiosis causes harmful bacteria to overgrow, damaging oral tissues and triggering inflammation. Beyond the mouth, dysbiosis affects systematic health by activating immune responses and altering metabolic pathways. The bacteria and toxins from the oral cavity can enter the bloodstream, promoting chronic inflammation throughout the body and impairing normal metabolic function. When there is an imbalance, harmful bacteria and their toxins can enter the bloodstream through inflamed gums, potentially contributing to cardiovascular diseases, diabetes, and other inflammatory conditions throughout the body.
A study reported that 2% zinc citrate toothpaste reduced gum bleeding and disease-associated pathogens, which will be elaborated later. Overall plaque levels also remain unchanged. Another study showed that zinc ions suppress anaerobic, odor-producing bacteria, explaining their targeted antimicrobial effect. Zinc ions function through two mechanisms. Firstly, they bind to thiol groups, neutralizing volatile sulfur compounds that causes bad breath. Secondly, they inhibit bacterial enzymes and disrupt cell membranes, slowing the growth of anaerobes even at low concentration.
From the literature review, we have chosen the Darlie Gum Care toothpaste as an intervention as it has active zinc citrate ingredients. According to Darlie, this toothpaste reduces plaque in our mouth, improves gum health, and controls odor, which is related to bacterial composition in our oral microbiota.
Our study aims to test whether 1 week of standardized brushing with a zinc citrate toothpaste can shift an individual's microbiome towards a healthier profile as compared to their baseline. From our literature review on the effects of zinc citrate, we expect to see a decrease in bacteria associated with periodontal inflammation and oral malodor, such as the bacteria listed here. Clinically, this would translate to less gum inflammation and reduced bad breath, reflecting a healthier microbial balance. Because dental plaque is a structured biofilm, we would also expect that the overall microbial diversity to remain stable, even as the composition becomes more balanced. In other words, the commensal species would persist, but the relative proportion of the disease-associated bacteria declines. Other outcomes such as inflammation, plaque coverage, and malodor reduction are anticipated but are quite difficult to quantify within our scope. Taken together, we hypothesize that the short-term use of zinc citrate toothpaste will selectively suppress pathogenic taxa, producing a distinct 16S compositional shift towards a healthier microbial community while preserving the oral diversity.
Our group used Darlie Gum Care Plus Odor Control Toothpaste as the intervention. We replaced our usual toothpaste with this product and did not use any mouthwash or other oral care products during the study. We brushed twice daily using a soft bristled toothbrush, following a standardized brushing video to ensure a consistent technique. Each time, we applied enough toothpaste to fully cover the toothbrush bristles. We flossed once every night using string floss before brushing. After brushing, we thoroughly cleaned our tongues using the toothpaste until they appeared visibly clean. Oral microbiota samples were collected in the morning before brushing at baseline and again 1 week later, also before brushing, for comparison.
To gain a comprehensive understanding of the oral microbiome, our study collected samples from different parts of the mouth to get the full picture of the oral microbiome. The mouth is made up of many different surfaces, and each area has its own unique mix of microbes. To capture this diversity, we swabbed 5 specific sites: the front teeth, bottom molars, tongue, inner cheeks, and gums. We chose the front teeth and bottom molars to capture the differences between smooth and grooved surfaces in the mouth. Research has shown that microbial communities on molars and incisors differ significantly, with molars supporting more complex and diverse bacteria due to their grooves and tendency to trap food, while front teeth or incisors hold simpler communities on smoother surfaces. By sampling both, we can represent these distinct oral niches more accurately. The tongue, inner cheeks, and gums represent mucosal surfaces with different microbial compositions. Including these sites helps us build a more complete picture of oral microbiota. This approach has several advantages. Firstly, it's non-invasive, covers a broad range of oral niches, and provides a more representative view of the microbiome. However, there are also some limitations. The microbial composition naturally varies between different areas, so results might differ depending on where the samples were taken. To make sure our results were both accurate and consistent, we implemented a standardized 1-week oral care routine for all participants. Everyone used the same toothpaste, Darlie Gum Care Plus Odor Control toothpaste, and we also controlled several other factors that I'm going to list in the next slide. Participants brushed twice daily, morning and night, using the same method and duration, guided by an instructional video. After brushing, they waited 2 minutes before rinsing to maximize toothpaste contact time. Flossing was done nightly and mouthwash was excluded to preserve microbial communities. Tongue brushing continued until visibly clean and no additional oral products were allowed. Standardized videos ensured consistent flossing and tongue brushing techniques. Everyone used a soft bristle toothbrush with the same toothpaste amount, about half the brush head length. Although retainers can increase bacterial load, all participants wore them during both sample collections, so results were unaffected. We noted retainer use to identify potential outliers, as retainers may influence bacterial load and composition. Participants with braces were followed for only 1 week, so braces had minimal impact. Though slight decrease in microbial diversity and increase in Fusobacterium and Aggregatibacter may occur, braces and existing dental issues were recorded to ensure any differences could be interpreted carefully.
One of the main limitations of our study lies in the variation in dietary intake, which we neither controlled nor measured. The amount of sugar, alcohol, or caffeine a person consumes can directly influence the oral microbiome, as different nutrients provide distinct substrates for bacterial growth, creating unique microenvironments that favor certain. In addition, studies have shown that personal lifestyle factors, such as hydration status, stress levels, and circadian rhythm, can also affect microbial composition within the body, including the oral cavity. The significance of these uncontrolled factors is that they introduce substantial inter-individual variability. This means that any observed changes in the 16S microbial profiles could result not only from our intervention, but also from background differences in participants' diets and lifestyles. As a result, there's a risk of drawing false correlations, which reduces the validity and reliability of our findings. To address this in future studies, we could standardize participants' diets by providing controlled meals with consistent nutrient levels, ingredients, and portions. We could also monitor sleep, stress, and hydration daily using questionnaires and factor these variables into our analysis. Lastly, using a larger sample size could help minimize inter-individual differences and improve the robustness of our results.